everyone. Today maths class will be looking at longitude and latitude. As you can see on the board, this diagram depicts longitude and latitude on the sketch. Now first of all, what are latitude? Latitude, as you can see, are these lines here and these lines here. Latitude are lines drawn on the surface of the earth which runs from west to east, but their paths are drawn either on the North Pole or on the South Pole. That is why you see the latitude diagram at this point here and at this point here. And secondly, longitude are also imaginary lines which runs from North to South Pole on the surface of the earth, but their paths are drawn either on the West Pole or on the East Pole, as you can see on the surface of the earth here. Now, having discussed this very quickly, we now need to look at the angular difference. As you can see on the sketch here, now this is what longitude and this is what latitude. This part is showing us the path at which they are being drawn. Now, if we have west-west, what do? We subtract them to get the angular difference. If we have east-east, we also what? Subtract them to get the angular difference. If we have west-east, we add. If we have east-west, we also what? Add. Now, for the case of latitude, if we have north, what do? We subtract them. Likewise, when we have south-south, we also subtract. If we have north-south, we add. If we have south-north, we what? We also what? Add. Now, what this thing is trying to show us is this. For us to calculate any part of the surface of the earth, we must fully understand the concept of what? Angular difference what? Very well. Now, well, we need to look at how to sketch this diagram on the surface of the earth. Now, I'm breaking them down into trick. Now, trick 1, if the latitude are the same, it is away from the equator. Now let's take this example to explain that. Now if we have 2 points on the surface of the earth as point A 70 degree east, 60 degree north, and point B 100 degree east and 60 degree what? North. What do you observe first? We observe that 70 degree east and 100 degree east are what? The same, just difference of what? Angles. And this part 60 degree north and 60 degree north is a constant. So from our trick, we are told that if the lats are what? The same, it is away from what? The equator. That is why you have this diagram like this. This point here depicts the equator, and this part what depicts the North Pole, this part depicts the South Pole, this part depicts the West, and this one depicts the what? East. Now since I am not drawing to scale, what do? I'll draw the smaller one first, which is what? 70 degree east. I'll draw it, then I'll label 70 degree east. I'll take the other one, 100 degree east. Since they are lying on the same position, I'll draw 100 degree east. And I'll take the part that is constant, 60 degree north, 60 degree north. Then I'll trace it to the point where they meet. Now this is point A and this is point B. They meet here. So this part becomes what? Our theta, which we describe as the what? As the angular difference to what? To be solved for. Now, how do I get my angular difference? Now, we know that angular difference is giving us, what do we have? We know that this one are what? The same. So what will it be? 100 degree minus 70 degree, which gives us what? 30 degree. So, from this diagram, we have been able to calculate the angular what? Difference between the points what? A, B on the surface of what? Of the earth. Now, we'll be looking at trick 2. If the longitude are the same, it is at the what? Equator. Now, let's explain that with this example we have here. Let's say we have 2 points. Point A, 60 degree west, 30 degree north, and point B, 60 degree west, 40 degree what? South. Now, we'll go back to our diagram. We'll draw again. Now, this is the North Pole, the South Pole, West, and East Pole. Now, from the North Pole, we have 30 degree, and we have, from the West Pole, we have 60 degree. From the South Pole, we have what? 40 degree. If you watch, this diagram is quite different from the other one. Now, the reason being that the long the longitude are the same. So since the longitude are the same, it's going to point downward to the equator. Now we're going to get our angular difference. So our angular difference will now be given as, what do we have? It will be given as 40 degree plus 30 degree, which will give us what? 70 degree. Now, I take that again. Our angular difference will give us 40 degree plus what? 30 degree. That gives us what? 70 degree. Now, we need to look at basic formulas used in calculating any position on the surface of the earth. So, now we'll look at trick 1. If we're asked to calculate the distance along the equator, and it can also come like calculating the distance along the parallel of what? Longitude. So, if we have any questions like that, all we just have to do is to make use of this formula, theta over 360 times 2 pi what? R. Now, let me take my time to explain each of them very well. Now, the theta here represents the angular difference which we are going to solve depending on the question given. And the R here represents the radius of the earth, which is approximately 6,400 kilometers. Now, our pi is given as 22 over 7 or 3.142. So, the examiner can tell us which one to use to solve the given question. Now, trick 2, when you are asked to calculate the distance along the parallel of what? Latitude. In this case here, we're going to make use of theta over 360 times 2 pi r cos alpha. Now, let me explain this one very well. Now, the alpha here represents the what? The latitude, while the theta represents the angular difference. Of course, our r still represents the radius of the earth, 6,400, and our pi can either be 22 over 7 or 3.142. And trick 3, if we're asked to calculate the shortest distance along the surface of the earth, we make use of this formula, beta over 360 times 2 pi r. Now, in this case, this one is quite different from trick 2. In this particular case now, the beta is given as 2 sine inverse sine theta over 2 cos alpha. So we are going to calculate for our angular difference, and we're also going to get our what? Our alpha. When we get that, we can substitute the value and get our beta, then we can now solve what? Directly. Now, let's look at this example.